Hello, everybody, and welcome to the latest area webinar. Really excited to have you here. I'm really excited to have this webinar. I often use excited when I do these webinars, so my apologies, but we're going to be here today with the Manufacturing Technology Center and listen to the work that they've done where they're solving real manufacturing problems. But before we jump into that, a quick introduction about the area for the people who don't know. The Area Augmented Reality Enterprise Alliance, as you can read, is a global membership-funded, not-for-profit alliance helping to accelerate the adoption of enterprise AR. Our kind of definition of AR is you can still see the real world. So it's not virtual reality, but augmented reality, which you can do through pass-through with the VR headsets and also see-through headsets and wearables as well. We've been doing a lot of work recently on the AI and AR glasses, which is something the area members are particularly interested in. Next slide, please. One really exciting thing is that the end of last year, we joined the EDM, Enterprise Data Management, is now called the Association, which has now got part of OMG, Object Management Group, which is a standards organization, the Digital Twin Consortium, and the area. And it's really brought a great focus on the importance of data and AI, which, as we know, to solve kind of business problems, bringing these technologies together as well as augmented reality. Really helps organizations and definitely pushing the kind of boundaries of what the technology can do. Next slide, please. To give you an idea who's involved in the area, we're in 3 different kind of segments. We have the enterprises who are successfully deploying the technology and have often work hard to do that. We have a number of software and services companies. The hardware side, as we know, has been really interesting over the last few years, and it's really exciting to see new players come into the market like HMS and PNC Solutions, who are bringing kind of new wearables as well as X-Real and Raven Compute. And then on the non-commercial side, we have a mixture of universities, standards organizations, and research and government organizations, which the MTC is part of. And Stuart and Nikita will be explaining a little bit about what the MTC does in a second. Next slide, please. Oh, yeah, sorry, another one. What we basically do boils down to these 4, what we call our strategic pillars. So we are and do a lot of thought leadership, and this is a great example of it today. Really helping kind of companies and business decision makers understand what the technology is, what problems can be solved, looking at case studies, actual examples, again today, and the ROI. Another great benefit of area membership is the networking, being able to kind of speak to, learn from, share experiences with real experts, and to help you and your company successfully deploy the technology. And again, today will be another example of listening to some great experts. The educate side, we see a massive skills gap. So we're actively working with universities to help define courses, offering guest lecturing and outplacements. But a lot of the work goes on about reducing barriers to adoption. We use the phrase pilot purgatory. And we have a number of different committees and communities that are working to understand and overcome some of those issues around security, safety requirements. And we have a very strong research capability as well. Next slide, please. So there are lots and lots, over 70 webinars that we've done over the years that you can find in this channel, and you've obviously, if you're listening now, you've obviously signed up to the channel, so please go and have a little look at all the different webinars that we've done. If we can go to the next slide, we've got some examples that we've done recently, some really interesting runs around the kind of networking side, some great ones about wearables, and also another one recently with Dan about some actual use case in the iron industry, in heavy industries, doing metalwork and stuff like that. So that's all available. Please go and have a look at those. Next slide. And also we have some fireside chats. Now these are very simple 10 to 15 minute video interviews, little snippets of insights from enterprise AR experts and supporting kind of people as well. It's a really kind of great way to get a quick download of what's happening and who's doing what and get some insights that way. So again, that's available on the area YouTube channel under the kind of fireside chats. Okay, right. So I'm in a second going to hand it over to Stuart and Nikita to introduce themselves, but please take the opportunity to ask questions. There is a little box under your screen where you can type any questions. We'll be picking them up at the end of the webinar. But anytime through the conversation now or through the presentation, please feel free to type some questions. Okay, right. I'm going to hand over to the real experts. So, Stuart, Nikita, thank you very much for joining us today. I know you've done some amazing stuff in the augmented reality and immersive kind of space. So I'm going to hand over to you guys. Thank you very much.
Thanks, Mark. Just a couple of introductions before we start. So my name is Stuart McLeod. I'm the engineering manager for informatics here at the MTC. I've been here about 4.5 years. And I've got a background in component automation, engineering, tool design over many years at Loughborough University in Jaguar Land Rover. Nikita?
I'll keep us going. My name is Nikita Pietrow. I'm a senior research engineer within the digital engineering team of the MTC, and the same team as Stuart. So my background is really broad, from material science to mechanical, and kind of the last 4 years focusing mainly around data within the manufacturing environment. And XR is kind of one of those areas that our team looks after. And our role is to help accelerate adoption of some of these technologies within UK manufacturing sector. So some of the work that we're talking about today is we're looking at XR as one of those key technologies that we're trying to accelerate and help adopt.
Thanks, Nikita. So today we're going to go just through a little bit about the MTC and what we're doing in this area, and just our where we focus our research and how we deploy our capabilities. And then I'll hand over to Nikita, and we'll go through the XR reality check. What's the current state of the art, and then we've got some examples that we've deployed, and we've got a particular case study on our battery disassembly cell, which was released last year. And then we'll look on what could be next and what we could go for the future. So the MTC is a member of the high value manufacturing catapult family. I believe we're the only one that's not linked to a university, but you can see we're right in the middle of the country there. We opened in 2011. We're a research and technology organisation, so we help the adoption of technologies and in the UK manufacturing area. In 2015, we opened a training facility, and we're training over, I think it's over 100 apprentices. We train Amazon apprentices, etc., that sort of thing. We've gone from pretty much zero in 2011 to £120 million turnover in last year, which is phenomenal growth, and we've got over 1,000 staff, of which over 600 are engineers. So where do we play? So we don't do the upfront research. What we focus on is that valley of death, or the bridge of opportunity, if you like, looking at taking the research and making that available to manufacturing and industry, and how they would go and deploy it and use that in the real world. And you can see there we've got the TRL, which is the technology readiness levels. We also look at the MRL, which is the manufacturing readiness level. So that's looking at the processes that go to make these products. And with our training facilities, we've also got the skills readiness. So you can see there's a delay. We need the skills to support all this technology as it goes through. So we focus in that 4 to 8 area. Now, we don't just do VR, XR systems. We look at a wide range of things. So we have our industrial transformation department that goes into companies, looks at their processes, looks at their technologies, and identifies how they can grow and how they can adopt new technologies and make their businesses better. We've also got a digital engineering team, which is what we'll go into later. And we've got our advanced production systems, who look at automation systems and the production systems that support it. We've got component-based manufacturing technologies. We are the National Centre for Additive Manufacturing, as well as laser processing. So there's some specific examples of manufacturing that we have in there. And we have our future skills area, looking at the skill sets we need going forward. But we bring all of those technologies, all of those departments together to solve real world challenges and provide solutions. So it's not just one team working on a project, it's that whole group that we bring together. So now we're focused on digital engineering. First thing we look at is smart, secure, connected manufacturing. Anything that you're doing in the manufacturing environment, you have to make it secure. Manufacturing is the largest footprint for cybersecurity attack at the minute. So we are heavily invested in that. We also do it looking at AI adoption, and one of the biggest areas we have in that is the test and validation centres around AI and cybersecurity. And again, that includes using XR systems to support those as well. We also look at digitalised supply chains to evaluate how those supply chains interact, and product and process development, which has got a lot of XR applications engaged, and that includes the life cycle analysis from the ground to the completion of a project. And one of the big things that gets used for XR is inspection, and that can be inspection in new environments, inspection in dangerous environments, etc., and that sort of thing. So informatics, which is the specific area we look at, again, we have these strands, starting with connectivity to make sure we start from a strong base, and that includes advanced wireless systems and industrial IoT. We're seeing a huge uptake on vision systems to augment most applications, including automation, quality control, environmental management, and that includes things like guided automation. So if you, instead of hard coding robotics, you can use the vision system to guide the robot to the exact position that you're looking to get to. We also integrate with ICT systems, so your MES systems, your ERP systems, a whole wide range of data that can enhance a production system. And building on top of that, we use AI to integrate this information and bring it to the operator and give him insight into all the information that's been gathered in those previous sections to support the advanced visualization. So I'm just going to hand over to Nikita, and he's going to continue from here.
Thanks, Stuart. So hopefully Stuart's given you a good overview of the Manufacturing Technology Centre, and then specifically our informatics team, which is where we sit. So for the next few slides, I'll talk you through some of the work that we've been doing on XR within the MTC. But as always with these kind of presentations, we wanted to start with a bit of a reality check on where XR currently is in manufacturing and where it is today. So over the last few years, and if you've been following the XR field, you probably know that there's been a huge improvement in the technology itself. So that the hardware is becoming lighter, more capable, more practical, and more suitable for industrial use. The software and the content that we're able to create within for XR is becoming better, more immersive and more engaging. And there are exciting parallel developments in things like AI, connectivity, computer vision, that are enabling more complex and more powerful use cases. Anything from AI assistance within XR to object detection, to just the ability to get up and walk around a facility with your headset rather than being tethered to a PC. And all of that evolution of the technologies is exciting, and we're keeping an eye on. But our main observation is that VR in particular is really mature already. And ready for industrial deployment, and with AR and MR catching up very quickly. But the question always is: so where is the value, and where manufacturers are already able to see the benefits today? And these are just some of those use cases. But training and skills development is probably still the strongest example of where manufacturers see value in using XR operationally today. Almost all manufacturers are facing skills shortages, requirements to quickly and continuously conduct knowledge transfer and upskill their engineers. The increasing complexity of the processes that these engineers work on requires them to constantly train and develop skills within the business. And XR gives that unique ability for people to try out and train and test processes in an immersive virtual environment before they get put in front of expensive and potentially sometimes dangerous equipment, as we'll go and look at some examples later. Next one is immersive data visualization. So again, increasingly we're dealing with more complicated data sources, large complex data that has to be not just visualized in a dashboard, but visualized it with the context surrounding that data. And again, this is where XR has a really key role to play. Enabling assembly and maintenance through augmented instructions is another use case that we continuously see appearing. So that ability to get hands off, and while your hands are engaged doing an assembly or maintenance task, to have instructions fed to you through through augmented projection is something that's really powerful. And then one we'll talk about in a little bit more detail in the case study later is around commissioning and virtual validation. So this is one of the more recent use cases, but it is one that is being increasingly used operationally. So being able to virtually validate processes before, as you're commissioning a system, to de-risk and prototype and make sure that the system will perform and operate as it's designed, and doing that virtually before you commit the physical resource, also spend the money to make the capital investment to build the process or new manufacturing line, for example. And quality control is similar. So being able to compare physical versus virtual models and make sure that the two align. So these are just some examples where there is already real value in manufacturing today from using XR systems. And the reason why these are successful is they help reduce risk, they improve the understanding of the process, they support the people that use that are in the manufacturing environment, and make them perform their jobs more effectively. And I'm sure there's many more that we'll probably list multiple slides just to list all those use cases. But there are others as well. There are others that are emerging, and there's still some barriers to overcome and work that needs to be done. So a couple we wanted to highlight, for example, is multi-user collaborative XR environments, going beyond just visualizing models or CAD models together in a multi-user environment, but actually being able to interact and deliver work in these collaborative spaces. So that's still something that requires some development. But it's really key. So I know Stuart comes from an automotive background, and a common use case there is around bringing people from across the country to review a physical process. Automotive do this with cardboard cutouts, where they lay them out on the floor, and everybody from across the country comes and signs off on the process. But being able to do that, for example, in a virtual environment where everybody can do that remotely, is really powerful. Or being able to do it for operations where you can't safely get people into that environment. So in the built environment or rail sector, or nuclear decommissioning use cases where you just can't get people into that environment. The other one is around large model visualization. So you'll see some examples later of being able to put relatively large CAD models into a virtual environment. But if we talk about entire facility scale, fully robust visualizations of facilities, entire manufacturing organizations, that requires extensive data processing, and we're probably talking about streaming data rather than hosting all of that data on the headsets. And then the final one is around streaming live data into these tools. So it's increasingly we're trying to get away from siloed XR applications, but instead those that are connected to the enterprise systems or live data that comes from the shop floor. And again, there's an example later of some of the work we're starting to do in this space. But the main message is we're increasingly seeing that the biggest barrier to adoption of some of these more advanced use cases is not necessarily technical. It's while there are still some kind of data management and integration challenges, it's actually organizational and cultural blockers that we have to overcome. And that's why we always encourage organizations to focus on identifying a particular operational problem or use case that they can solve with XR before sort of jumping ahead and getting excited about the hardware and the technology. And that's really critical, because if people don't fully understand the problem, or don't trust the technology that's being introduced, or if it disrupts existing processes or workflows, those can act as really big adoption barriers that prevent organizations taking an XR application or use case from a proof of concept pilot to an operationally used assets. And that's exactly where MTC gets involved, and that's what we are positioned to do.
Just before you carry on there, Nikita, I think one of the things is we look at the way people ingest data. You know, a lot of people get snippets of information and they want that information exactly where they need it on the shop floor. They don't want to go back to the office and use the phone or whatever. They need that information right there. So these XR applications give people information exactly where they need it.
Mm-hmm. And quite often the data exists already in some enterprise system, in a manufacturing execution system, or live data, and it's just a case of bringing it to the user in with the correct kind of method of presenting that data. Thank you, Stuart. So as I mentioned, this is exactly what MTC is positioned to do, and our role is not to simply demonstrate technology and build fancy proof of concepts for XR, but it's to help accelerate the adoption of intelligent, connected digital technologies by showcasing their value and their benefits, by de-risking some of those integrations and you know how we build XR not as a siloed system but connected into a wider ecosystem of enterprise applications, and then providing that sort of tailored adoption pathway for that specific organization, so that for them this is how they need to roll it out based on their specific operational context. And we usually meet organizations at different stages on that journey. So it could be somebody that's starting out, somebody that's building pilots, or somebody that's already established and they're just looking to scale up their deployments. So some of the there's a few examples here of the kind of projects that we do. On the very start of that journey, quite often we look at realistic recommendations on use of XR within enterprises. So doing a practical assessment on the technology, the use cases, the readiness of the organization to deploy this technology, and sort of prioritizing which ones they should focus on. If they already have a good use case selected, the next stage is around those proof of concept pilots, building these connected applications that show how these apps can be used as part of a bigger interconnected system, and help de-risk that investment to make sure that the use case is valid, and the investment into the hardware and maybe the hosting service and the capability of skills needed to maintain and build and maintain XR apps is justified. Quite often this requires real data. So as you know, there's a theme emerging through for our slides here. We like to, our focus really is on that integration and data connectivity. So of course for us, secure connectivity of shop floor data, that reliable, secure connectivity from diverse assets that we have in a typical manufacturing facility up into these visualizations and XR apps is a big focus for us. And as we get more interconnected, the immediate question and big blocker is around cybersecurity. So one of our current research areas and focus areas is around resilience and security of some of the devices, and XR headsets, for example, are devices that can be deployed on a shop floor. So our role is to help validate that these devices are secure and without undisclosed communication interfaces or embedded 5G SIM cards, that to protect the data that organizations are quite often need to protect, and ensure there's no security incidents. But then there's the other side of that coin around the security incidents is the use of XR to simulate or model or predict or prepare for security incidents or help respond. For example, an application could be to visualize location of key assets in an emergency. So sort of security this kind of works both ways. The next one is around inspection and operation intelligence. So one of the use cases we'll quickly discuss, I believe on the next slide, is around enabling that immersive visualization of really complex inspection data sets. So by better visualizing and contextualizing some of that data, we can build more trustworthy digital systems. And XR has a really big role and is a big enabler to play for that. And then the final, some organizations have already done all this. They've deployed, they've got connectivity, they've got the XR capability, they've deployed it, and maybe it's just around scale up. So testing and validating that the proof of concept of the technology is ready to be safely deployed into a production environment. So we try to support organizations along that journey of all sizes, so from SMEs to large aerospace and defense organizations that are looking at using XR tools in a production environment. So in the next slide, we just wanted to give you some examples of those before we jump into the kind of the main case study that we wanted to focus. Obviously, the kind of XR projects that we've had opportunities to work on. And these are just some of the less customer-oriented ones that we are allowed to share. So there's a little bit of a commercial aspect there. But I can talk about some of them at least in a bit of detail. So of course, VR, virtual reality training, remains one of the kind of the most mature applications, and one we're consistently seeing and working with our member organizations and customers, because it has proven record and consistent value for workforce development. So the example screenshot on the left there is from a VR training environment for additive manufacturing. So within which we can do a complete training on that machine, from the initial setup and commissioning to calibration, to material loading and machine setup, to build process and post-process training as well. And in that environment, the operator is able to interface with the HMI, the machine, the components, and all of the surrounding auxiliary systems on that machine, to completely virtually complete 90% of that training, so that when they go on site, they just practice the hands-on stuff that you can't really simulate, like handling really large-scale metal parts, for example. AR is the next area. So augmented reality has applications for training, but also around maintenance. So some of the projects that we've done with the likes of Rolls-Royce SMR program is around overlaying live data or operations guidance or maintenance instructions on top of physical assets to help with that maintenance activity, or make sure things are done correctly and safely. Visualization of data over assets is in general quite a helpful thing for manufacturing. So there's an example there of a chemical manufacturing process, I believe, with data that can be overlaid to communicate the state of the asset that's located somewhere else. But that's applicable across a range of different use cases. So, for example, visualizing live data from production shop floor overlaid over the digital 3D replica of that facility to give you contextual information about statuses and the location of key assets and products, etc., within the facility. There's loads of applications of that sort of VR visualization with live data streaming. But sometimes it's a significant amount of our work also focuses around discovery and implementation planning. So with a customer from the rail sector, for example, we've done that full journey. So they came to us first with a project to look at what possible applications of XR exist within their organization, then prioritizing those, looking at the ease and benefit of the development and readiness of the organization and readiness of some of the technology to help them select those sort of quick wins versus more longer term investment projects. And then we went and built some of those pilots. So the screenshot there is of one of our engineering colleagues from the metrology team conducting some non-destructive inspection of a railway arch, so looking through the corrugated steel into the condition of the brick wall beneath that surface. And that produces a really rich data set. And in particular, we analyze it using AI models to locate defects below that surface of the wall. So things like big cracks that appear in that railway bridge that we need to know exactly where they are located. Unfortunately, that's a really difficult data set to without any kind of visualization to understand, because the user, they just get an X, Y, Z coordinates. That doesn't really mean anything to a metrology engineer. So one of the applications that we worked with them is actually overlaying defect data onto the 3D replica of a 3D scan of that exact railway arch. So we get precise location of the defects, description of what that defect is, and how that defect has matured over the last few years of the asset. So you get a really rich data set that's projected and visualized over the physical asset that then allows the operators to go and remove that particular panel and conduct maintenance activities on just that section of the wall, rather than stripping out all of that kind of material. So just one kind of example of the kind of project that we've worked on in the built environment sector, as well as manufacturing. But really the one we wanted to focus on in a bit more detail today is the most recent project that we've worked on. And that was a project called Charge, which delivered the UK's first automated prototype battery teardown facility. And we'll focus mainly on the visualization elements here, but if you search for that Charge and MTC, you can probably get some more information about that project if that's something that is of interest. But on kind of the highest level, the objective of that teardown facility in a container was to enable safe disassembly of electric batteries that come back from service. So they typically arrive with maybe with damage or with unknown life cycle or different types of batteries that have to come into this disassembly facility and be dismantled using a robotic system. Of course, because human operators are not allowed to do this due to the dangers associated, so it has to be an automated solution. And XR has a really big role to play in this, and unfortunately, there's a couple of challenges we have to overcome. So first of all, we need a way of visualizing that environment to validate that the physical asset will operate as intended. So that's sort of commissioning activity. That includes the robot paths and processes, so simulating the movement and positioning and location of all of the key physical assets in that cell, and the recipes, so those actually the disassembly steps that have to be followed to tear down different types of batteries. The Tesla battery might be disassembled completely differently from Nissan battery or from any other automotive company. So being able to virtually validate some of those recipes for dismantling and make sure that the space is correct and the process is set up correctly. The next step is around safety critical areas. This is in a container, and once this goes live, you can't open a door and have a look. So we need a way of visualizing what's happening internally within this. And there are some live cameras that again we can connect to. But that full 3D visualization can help with things like training or decision making is really beneficial. And then the training is the next use case. So again, that visualization of the asset can enable us to train the operators virtually on operation of this asset even before it's been physically built. Unfortunately, though, it's not the easiest thing to build something like this, as you'll all know, that uploading these really complex large models into a VR environment presents some challenges, especially when you try and host this on an XR headset. And what we found is, when you just do it directly and try to build this as a dedicated app for a headset, the performance isn't there, even with optimization. And that can really impact user experience. And we even had some operators that became dizzy and nauseous based on just putting the models within the headset. So those are some of the challenges that we wanted to overcome. And our solution was to develop a kind of a unified app that brought XR together into a 5G connected manufacturing system. So first of all, this included a Unity app that allowed the operators to interact with all of the different use cases. It was then hosted and offloaded via HoloLight and broadcast and connected to the headset using a private 5G network that we have within our shop floor. And then live data was then fed from the real physical asset that was located outside in that container to accurately reflect the current condition and state of the physical asset. To do that, we created a unified namespace, which some of you online, if you're not familiar with, is essentially an architectural approach for creating a single source of truth for data within our process, and data that's really clearly named and located. So applications can very easily subscribe to data that's hosted in that single source of truth, and sensors, devices, robots can publish data and update that state that again is then reflected in Unity. So what we did is create that data pipeline first of all. So we needed to connect the Unity app to the live data, and for that we used a combination of MQTT for kind of industrial connectivity protocol, or HTTP and various other protocols to connect data into the Unity application. And we have to have support a diverse number of protocols there because we had to deal with live video feeds, video playbacks and live CCTV camera feeds from inside the real facility, as well as real-time data from the sensors and PLCs on some of those robots. And And that data is a significant volume of data that had to be streamed, which is why we switched to the 5G network to provide to stream that data with significantly reduced latency. We then have to develop some user interfaces, and that, of course, that entire application, and that experience which you're seeing there in front of you, to provide user interfaces to guide the operator through the different training, maintenance, operation awareness use cases, as well as sharing real data feeds into the application. We also utilize the physics engine that's built into Unity. It's a very lightweight engine, but serves a purpose here to do that initial validation of some of those robot kinematics. And then you briefly saw towards the end of that video some use of vision guided operation automation. So using the synthetic environment to generate synthetic data that can be fed and to train the actual robotic systems. So looking at what does the robot see in that particular operation, and then generating that data to feed into AI models that can be used to detect things like bolts and cells, different components of that battery. And we've done separate projects just looking at that. So yeah, as you can see in that video there, we've seen exactly what the robot sees in that instant, and using that to train AI models. There's a massive amount of work that went into that project. It was a cross MTC activity across multiple departments. So I'll pause there in case, Stuart, if there's anything else you want to add, because we can talk about this.
I guess the only other thing is overlaying this model onto new batteries that you may, for example, I think you use the Tesla battery. If we put a Tesla battery in this, we can overlay the facility and start interacting with a real battery and the virtual system to start creating those recipes in that mixed environment. And that's going to be one of our focuses for the future.
Yeah, but perfect link into the kind of what's next for us in this topic. So we're not done with this project. It's still work in progress, and there's more things that we want to do. And the big one is around that multi-person collaborative environment for automated recipe definition and battery variants. So being able to put multiple users into that immersive environment and create recipes for automation and validate them virtually. And as I mentioned, that sort of that visual feedback to help train some of those models and develop the programs required for the robotic system is still something that we're looking to develop. And of course, a big learning from us from this project was, as in previous projects, it's an extensive amount of effort that goes into developing these XR applications. So not just the 3D environment and all the data connections into it, and all the assets that have to go in and the animations for those. But now if we need to make changes, again, that requires the same team that works to go and recreate and update these and maintain these, which is a really intensive activity. So one of the things that we're looking at is to bring some of our AI capability into this, and particularly generative AI for design, to see the role that could play in creating some of these XR experiences. Both for helping accelerate the development of them, but also deployment and maintenance of some of these applications. But ultimately, this is specifically for this project. But for us, the bigger picture, as we talked about at the beginning, is we see XR not as an isolated capability and something that should be siloed or a shop floor, but something that plays a part in a bigger sort of complete digital representation of a manufacturing operation. So we're talking about building towards complex cyber physical systems and digital twins that bring all of these different capabilities together to achieve functional objectives that individually those systems can't do. And digital twins is a massive topic, and there's a lot of we could spend hours just talking about that alone. But across the MTC, we're quite fortunate because we have really broad capability in this space. So from within our team, we look at the connectivity to ICT systems, AI, vision, cybersecurity, all that data analytics and data science side as well. And of course, as XR as a key enabler. But then within other departments as well. So our modeling team has got the capability in process simulation, modeling, discrete events, data processing, and creation of automated simulation workflows. And all of these technologies can come together to develop digital twins. And for us, this is sort of the end goal. It's bringing all of these capabilities, all of these technologies together into these complex cyber physical systems where we have real data from the shop floor being collected through ICT systems and industrial IC solutions, vision systems, being fed into a digital twin layer where we can run models, analyze data in real time, predict outcomes and future state for assets. Use this for things like defect detection, schedule optimization, process planning, automation of physical processes, or even directly controlling manufacturing processes. So in our charge use case, for example, we could we have connection into the PLC. We could give commands to the robot and stop operation, start operation, load the next recipe. All that can be done from the virtual environment. But of course, none of that is useful unless it's exposed to users in some way and other systems that have the ability to control this digital twin. So through the interface layer, through SCC integrations, but also through XR, we are then able to operate these digital twins, kind of connecting it to all of these additional systems. And of course, kind of the last one on the very right, we can't forget about cybersecurity. These kind of systems have to be built with cybersecurity from the ground up, so secure by design. Because if we're talking about the systems that we can control, a physical robot on the shop floor in an aerospace environment from a headset, that system has to be has to be very, very resilient and robust and completely trustworthy. So cybersecurity has a really big role to play in that as well. Okay, so I think we're sort of coming to the end of the slides. So just to wrap up what we covered today. So I guess from why XR matters for UK manufacturing at the moment. Adoption, as we discussed, adoption of it is growing and accelerating because the technology underlying it is maturing. So some of those more ambitious use cases that have been stuck in that proof of concept stage are becoming more and more achievable. So things like virtual commissioning that we talked about, these use cases are becoming possible. And MTC supports organizations along that journey. So we sit along that entire life cycle of organizations' adoption of XR, from their first strategy to identifying those use cases and opportunities, to building those solution architectures of how everything connects together, and proof of concept pilots that prove that it can be done, and then eventually to the scale-up support, so helping build that roadmap of how exactly the steps the organization has to take to deploy this solution. There are already use cases where this is proven and being used today. So for training, for data visualization, for commissioning support, these are mature use cases. But to get to those more ambitious ones, there are still some blockers to overcome around the cultural adoption, that kind of unclear value around some of these use cases sometimes, the integration challenges to make sure this is not a standalone siloed application, but something that sits connects into the wider ecosystem within the organization, and then overcoming the operational risks. So when you deploy technology that maybe isn't as well established, there are of course operational risks that have to be handled. And for us, the kind of the focus now is in that bigger picture and building XR as part of a connected manufacturing digital twin on a organizational scale or facility scale. So the key message from us today is, I guess, importance of that starting with an operational problem, not the headset. As I mentioned, it's very easy to go and get excited about the latest headsets and look at the hardware side before we fully understand the operational problem. And it's really important that the hardware is selected, to match the use case and the operational challenge. There are still some risks around adoption that have to be overcome through operational trials that put the technology through its paces in a real representative environment, not in a kind of standalone lab ecosystem, but in an operational environment is critical. And the biggest blockers are not necessarily purely technical anymore, and mostly non-technical, but instead organizational and kind of workflow and integration related. And so the final message is that XR is most useful when it does solve a real industrial bottleneck and problem. That's when you can overcome some of those cultural and value challenges, and when it's integrated into wider digital ecosystem. So that's it from us in terms of the slides. So yeah, big thank you for joining today and for your attention. And if you want to get in touch, please do. If you scan those QR codes there, it should give you the email address for Stuart and myself. And of course, if you have any questions, then you're more than happy to answer them now. So please feel free to pop them into the question section on the right hand side.
Perfect. Thank you, Nikita. And again, I'd emphasize that bit about questions, but I've got a few for you to get things going. You talked a lot and very well about some of the blockers, but have you got your kind of top 3 tips you could give to overcoming these blockers? Especially in the manufacturing kind of environments as well. It's tough and it's interesting. So what kind of things could you give as a tip on the 3 key blockers that you see?
I think probably I can start with one and I'll hand over to Stuart for a second. So for me, kind of, I guess the first one is starting with that and a really good understanding of the challenge that you're trying to solve. That helps communicate some of the benefits and the impact that deploying XR could have, and quantifying some of that benefit. So that helps communicate with some of the stakeholders that you have to inevitably have to persuade within the organization. So that's kind of step one, I think, is that establishing the challenge and quantifying the benefits.
Can I, before you move on from that, and it, I absolutely agree. It's a really good thing, but how do you do that in practical terms? I know this sounds a bit strange, but we often say about, well, you have to have a problem that it's a really good problem. In your experience working with these manufacturing companies, what kind of process do you go through? How does that look like on a day-by-day basis?
Yeah, it's a good question. And that's usually the hard bit. Is we all know it's important, but how do we do it? Mm-hmm. So I can give you a practical example of that rail sector customer that we worked with. We had that exact challenge. They knew they wanted to use XR, but they didn't really have a clear pathway of what that meant and where they could use it within the organization. So the way we did it there, as one example, is we conducted some structured workshops within the key stakeholder groups that of those specific processes and operational teams that we knew there was opportunities with. For example, the training and development team or the health and safety team. We looked at previous experiences. We looked at existing plans and existing deployments, if any were there, and also aspirations. So they all quite often had really good ideas because they are the boots on the ground. They know exactly their challenges. They know exactly what their needs are. So those interviews were critical to understand the real shop floor experience and opportunities. And then from our side, we then took that information and did almost like a matrix assessment of opportunity versus technology. So what are all the possible combinations of VR, AR, MR, and surrounding technologies, and how can they help in those different use cases and challenges? And that gives you a massive list of ideas, and then it's around prioritization. So you look at the impact, the benefit that it would bring, but also the challenges and the readiness of the organization for this, readiness and the capability of the technology. So you end up with this kind of really comprehensive, methodical assessment of your use cases that then gives you a really clear, quantified, weighted value at the end that says this use case is the easiest, the quick win, biggest impact, and the lowest investment, versus something like huge impact that requires 5 years of development. So let's work on that longer term. So it gives you that sort of more practical, evidence-based and quantified measure for some of those use cases. So it's a very long answer, but hopefully...
No, it's a great answer. And I think one of the things we're working on within the area you may be aware of in the Human Factors Committee is kind of a innovation kind of framework, going from making sure you do the right work to define what the problem is, like you were talking about, but then all the other parts as well, anything from kind of diffusion to a great user experience to understanding the ROI. And I think as an industry, we need to get better at that kind of whole end-to-end bit. I hear a lot of people, and it's great that you say that you need to solve real business problems. It's something I often go on about, but kind of going through the other steps as well is something that we all probably can tell and show more, to be honest.
I think one of the things that's come out during this presentation, it's not the models and how it's represented, just it is the data that goes behind it, is the process that an operator that needs to do. So we had the example of the HMI being where the operator wanted it. It's always with me. I can call it up. I can see that. I can see the error messages on the machine. I can see the operating parameters exactly where I need it. I don't have to go and walk around the machine to do that. So then the system becomes, rather than I could use AR to help fix my problem, is I have to, because it gives me all the information where I need it. I can sign off things. It becomes part of my processes. And as I've always said, it becomes my favourite screwdriver for fixing the problem because it gives me what I need to do my job.
Perfect. That's great. Thank you for that summary. One kind of last question for me, and we can't get away from AI at the moment, and I'm sure in the manufacturing space it's the topic of conversation. What are your thoughts about AI and AR working together, and what kind of examples, and how in your kind of strategy, how do you see the two working together?
So yeah, of course, AI is a really big part for us. So sort of two separate teams within our department that work on this. So from AI side, we look at AI governance, AI trustworthy AI, and best practice for developing AI models. And on the XR side, our focus is really on that integration. That's sort of our core capability. So I think for me, it's where the two come together. Is how do we deploy AI applications that are connected to real data and serve and provide that analysis, contextual object detection, the AI assistance within an XR environment. I think is a really interesting research area. This AI is similar to XR, and probably even more than XR, is a field that's growing exponentially, and we have to every month we're almost working on different technology. So I think things like generative AI, agentic AI, object detection all have really big role to play for XR. I don't know if anything you want to add to that, Stuart.
Yeah, just in the, when you're using these systems, you can quite quickly use the large language models to ask questions of your production system. What was the technical availability of this machine last month? What was the last breakdown? Have I seen this problem before? And we have all of this information, but using AI to gather that and bring it back again into the headset or the glasses to give the information I need, where I need it, when I need it. So the AI is a real enabler for that data integration piece of work.
Yeah, especially as you mentioned, if we reduce that form factor from a big headset down to smart glasses, that you don't need a screen. It's just enabling that connectivity and that visual data capture from your surroundings and feeding that into AI models that maybe live on the edge or live in the cloud. Things like 5G that then make sure that things quick and intuitive. Kind of interesting intersection of all these technologies.
Yeah, can I just real quick add to that bit, and I'm kind of interested in your view on this. In some manufacturing use cases, the use of kind of AI, like you mentioned, Stuart, I'm assuming won't be allowed. There are certain processes that they need to follow, and almost like going to the step-by-step kind of guide and stuff like that. Am I right in saying that, or do you see examples where AI can be used in every little nook and cranny?
It depends on how you deploy your AI. If you deploy it as either small language models local to the machine, you can start using those, right. Or even large language modules that are contained within your facility. So you're not using the public view of it, you're using the on-premise version. Yeah, they are more acceptable. Quite right. We probably wouldn't want a public LLM asking about my manufacturing facility, because people will know what I'm producing, where my problems are, that sort of thing. So yeah, there's a lot of work going around that, especially around the small language models as well, to give you real information about what's happening in your environment.
And that's an important consideration for XR, I think, as well, because to host some of these LLMs, you have to have really extensive compute, which often means it's very unlikely you'll be able to host really robust models on the headsets. So it can't be local; it will have to be in private cloud or in public cloud. So how we overcome those challenges is a really interesting research topic, I think.
Indeed. Okay. Well, thank you very much, gentlemen. We'll stop it there. I don't see any questions from the audience. Thank you very much for those insights. That's really great. This recording will be made available almost immediately, I think, and we'll be putting some social media kind of post out as well. So thank you very much for all of your work, and thank you for people who've been listening. Now you can go and watch the football if you're interested. All right. Thanks ever so much. Thank you, guys. Cheers. Goodbye.
Thanks all.
Bye-bye.